Hello everyone. Welcome to today's session on electricity. So in electricity today we will look at Ohm's law. What is Ohm's law? Right. So what is Ohm's law? Right. So there is a scientist named Ohm. So he has done some experiment. So before we define what Ohm's law states, let's try to understand what experiment was done, and from that experiment what he has derived. Right. So let's say I have a circuit here. Okay. I have a circuit which is connected to a battery V with potential difference V, for example, right? And this is the plus and minus terminal. And I need to keep on adding the batteries. So I am taking the circuit like this. Okay. Let's say this is my initial circuit. Okay. Now this is connected. This is connected to a resistor. Okay. And then it is connected to a switch. And then it is connected to an ammeter to measure the current. Okay, and here I have a voltmeter to measure the current. Sorry, voltmeter is used to measure the potential difference. This is the plus terminal and this is the minus terminal. Now, so this circuit, which has a battery source, which can supply the electric current, and then I have a resistance R. Okay, I have a resistance, which is like a bulb. Okay, in earlier cases we had bulb, right? So here I have a resistance. Let's say that resistance is nothing but a wire. Let's say I have a wire XY, a wire, a wire which is kind of a spiral. I just put it as a current conducting material. Okay. Now, and across that wire XY, I have attached my voltmeter to measure the potential difference across that uh, XY wire. And then I have a switch that is closed. Switch closed means the circuit is open. Sorry, the circuit is closed. The current is flowing through the circuit. And then there is an ammeter to measure the amount of current that is flowing through the circuit. So now, when I have one battery with V amount of potential difference that battery can supply, I have closed the switch and sent the current. So when I sent the current I, right, then I recorded the readings of both voltmeter and ammeter. So in that case, current through the wire I have noted down here. Okay, let's say I got some value here, maybe like 0.5 or something. Okay, for reference. And then at the same time, I recorded the potential difference as well. Let's say that is also 0.5. I'm just taking some rough values here. And then V by I calculated, I got that as 1. And then what I did was I added another battery of same capacity to this circuit. So then this will be the plus terminal and this will become the minus terminal. Now I have 2 volts potential difference in the circuit, and then I recorded the current using ammeter, that is, let's say 1 amp, and the potential difference I got as 1 amp. I'm just taking, and V by A I calculated, I got the value as 1. Then I added another battery of same capacity. Okay, now this becomes the negative terminal. This will go away. Now I have 3 batteries of same potential difference. So now this became, let's say, 1.5, 1.5, and the V by I ratio is 1. And then I added another battery, and now this is like a permanent. Okay, so with V volts. Now this is the plus terminal, and the last one is the negative terminal, and this can supply 4 times of the potential difference that the one battery can supply. Now, let's say I got a current reading of 2 amps and the potential difference of 2 volts, and this value is 1. This is what Ohm has conducted an experiment by adding the potential there, by adding the source. That means more current. By passing more current, he has observed what is the ammeter, I mean the current in the circuit as well as the potential difference across that XY wire. So based on his observation, he recorded the readings, and what he observed was V by I. V by I always came as a constant. That's what he observed. So when V by E is constant, and also the other observation he did was, as he increased the potential difference, the amount of current flowing in the circuit has also increased. So V is proportional to I. So if it is, for example, if you see, I have one battery, I got 0.5 current. I have added 2 batteries, I got 1 amps current, like that. So the current, the amount of current that flows in the circuit is proportional to the potential difference, is what the scientist Ohm has figured out. So, and also what he did was, that constant is there, right? So this constant he named as R. Okay, so he said V by I equal to capital R, where capital R is the resistance of the wire XY. Resistance of the XY. This wire is there, right? Which we kept. So that R is resistance of that wire, and that remains constant anywhere. Okay, that remains constant throughout the experiment. So what we can say about Ohm's law? Ohm's law states that the potential difference, I will write as PD, the potential difference in the circuit is proportional to the amount of current flowing through the circuit. Or alternatively, you can say the amount of current in the circuit is proportional to the potential difference in the circuit. Yeah, that's even better. Okay, so the amount of current. So the amount of current in the circuit is proportional to the amount of PD, that is potential difference. So I is proportional to V, or V is proportional to I. That V by I is a constant. That constant is resistance. So the amount of current in a circuit is proportional to the amount of potential difference in the circuit at constant temperature. Why he stated constant temperature? When the temperature changes, the material conductance will also change. The amount of current that material XY is made of some material, right? Maybe an alloy or something. So that will change. So that's why at constant temperature, the amount of current flowing through the circuit, the amount of current in the circuit is proportional to the amount of potential difference in the circuit. So that is Ohm's law. So that states V proportional to I, V by I equal to R, or we also can write as V equal to potential difference equal to I, the amount of current, into R. R is the resistance of that material. So resistance is basically the opposition to the current flow. Okay. So if no resistance, the current will flow easily. If there is a little bit of resistance, current will, it is an obstruction to the current flow. Resistance means. So different materials have different resistance. For example, rubber or wood. So wood is a conductor of electricity? No, right? So wood has highest resistance. That's why it will not allow the electric current to pass through it. You understand the difference, right? So the more the resistance, the less the current can flow through that material. You understood? So that is about resistance is the property of a material to allow or obstruct the flow of electric current. You understood? All right. So let's see this. Now, from this table, if we see what we have done, we keep on adding the number of batteries, and then we observed different at a different amount of potential difference we supplied. We observed I and V across that circuit. Then we got different values, right? If we draw a graph, right? If we draw a graph to the potential difference and the current, we'll get a straight line. So this straight line is nothing but the slope. The slope of the straight line is nothing but our resistance that equal to V by I. Okay. Now R is the resistance. So resistance is basically what? Resistance is the obstruction offered by the material for the flow of current So that means it is the amount of resistance that a particular material can offer against the current to flow to pass through it. Okay, so here what are the units of R? So now R, hold on guys. So R units can be, R is V by I, right? So what is the SI unit of V? V means potential difference, that is volts, by what is I? I is electric current. So V by, so it's volt per amp. Or there is another unit, the SI unit of R, that is resistance is denoted by like this, and by the name of the scientist, that is Ohm. So this is the symbol. Okay, it's like a horizontal line with inverted U and the horizontal line. So this is called Ohm. So we can say a wire, a steel wire or a copper wire has 10 ohms resistance, 20 ohms resistance. You understood? So Ohm's law has invented that the V is proportional to I, and V by I for a particular material is always constant. That constant is nothing but the resistance of that material, and that resistance of the material is constant at constant temperature. And how can we find that resistance of a material is if you know the amount of potential difference in the circuit and the current flowing through the circuit, then V by I, you can get the resistance of the material. And the SI unit of resistance is by the name of the scientist itself, that is Ohm. Okay, so we can say R is 5 ohms, 10 ohms, like that. Understood? So that's about Ohm's law. This is very important in for the board exams. So Ohm's law, you can just draw the circuit and draw this table and explain what you have done. So you keep on adding. First, you have one battery and then you record the readings of V and I, note them down, and then add another battery source and then note down the readings. Next, the third battery and then fourth battery, note down the values for V and I and calculate V by I, and you will get that as a constant. And if you draw a graph, it will come like this as a straight line from the origin. Okay, now what is resistance? Resistance is the obstruction offered by the material of the wire for the current to pass through it. So R is V by A, V by I, and the unit of resistance is ohms. Okay, so that's what we learned. And now let's look at like so we said resistance, a particular wire has some amount of resistance, right? So what factors this resistance becomes? For example, I have a thin wire, I have a very thick wire. Will both the wires offer same resistance? No, right? Because thinner wire has lesser resistance and thicker wire should have bigger resistance. So let's see how that matters here. So it's based on a length. What will happen if based on the length? So the resistance R is proportional to L. That means the lengthier the wire is, the more the resistance is. So the resistance is directly proportional to the length of the wire or the conductor. Then about area, cross section, right? So let's say I have this much wire whose resistance is R1. Now I have this much wire whose resistance is R2. Now, in this case, R2 is always greater than R1 because the resistance is directly proportional to L. That means the more the length of the wire, the more the resistance of the conductor. Now, what happens with the area? So with the area, resistance is inversely proportional. That means the more the cross-sectional area, the less the resistance is because if the wire is thicker, right, it can have free space for electrons to flow easily. Okay, so what is resistance? The obstruction of electricity, right? Electric current flow. That means obstruction of electrons flow, right? So here R is inversely proportional to A. That means, let's say I have this wire whose cross-sectional area is, let's say, A1, and whose resistance is R1. I have another wire of same length. Okay, the length is important here because the different, if it is a different length, then we will have different resistance. So let's say the cross-sectional area is the circular, right? Wire is, if I cut the wire, it is in a circular shape. So if this cross-sectional area is A2 and the resistance is R2, then I will say R1 is greater than R2. Where here A1 is less than A2. The area of cross-section is, for the first wire is less than the second wire, but the resistance of the smaller cross-section wire is greater than the resistance of the thicker cross-sectional wire. So if I combine these two, can I say R is proportional to L by A? So with length, it is directly proportional, and with cross-sectional area, it is inversely proportional. If I combine, I can write R is proportional to L by A. If I replace this proportionality with a constant, I can take this as a rho. It is like a P, but it's not P. Okay. Then I can write it as rho into L by A. So what is this rho? This is called rho. This is how we pronounce it, rho, and this is called resistivity of that material. Resistivity. So what is resistivity? From this formula, I can say rho equal to resistance of the material into the cross-sectional area by the length of the material. So this is the formula for rho, which is resistivity, that is rho L by A. Then what are the units of the SI units of resistivity is, so what is the resistance units or ohm into what is cross-sectional area? Meter square, right? Area is meter square by length is meter. So meter you can cut it. So the unit is ohm meter. Ohm into meter, or we can just say ohm hyphen meter. So the SI unit of rho or resistivity is ohm meter. Okay, so here what we learned, a new term, that is resistivity. Resistivity is rho equal to RA by RA by L. So it is resistivity is a property. Okay, a property of a particular material. Like a silver wire will have different resistivity, and a copper wire will have different resistivity. So rho equal to RA by L. That's how you can find the resistivity of that particular material. And then the units are ohm meter. Okay, so that's what we learned, like what factors that this resistance depends on. It is the length of the wire and the cross-sectional area of the wire. With the length, it is directly proportional, and with the cross-sectional, it is inversely proportional. So R is proportional to L by A, R equal to rho L by A. So we can say rho is the resistivity, and that resistivity of that material equal to RA by L. Okay, hope you guys understood what is Ohm's law and how the resistance depends on the different factors like the length and the cross-sectional area of a conductor. Okay, now this is the table that you have in your textbook, which says the different materials and their resistivity. The resistivity is a property, right? How much resistance that material can offer to current flow. That is your resistivity. So electrical resistivity of these substances at 20 degrees. Why he has given 20 degrees? Because the resistance will be measured at a constant temperature, because if the temperature differs, the resistance can also differ. So that's why at 20 degrees, these are the values for the resistivity for different materials. So conductors, so which allows the electricity through them very easily. So if you see that, so this has very less resistance, silver. 1.6 into 10 power minus 8. That means it's kind of negligible resistance that silver wire can offer. Then copper, that is also right like that. If you see, the least resistance is by silver in the conductors, and the highest is manganese, that is 1.84 into 10 power minus 6, but is still, that is also still less. Okay, so that's why they are conductors. Then alloys means the combination of metals, right? So constant 10 has 49 into 10 power minus 6 ohm meter, and nichrome has 100 into 10 power minus 6. Alloys are also conductors of electricity because they will also allow the current to pass through those alloys. Now, insulators means the ones which will not allow the current to pass through. So if we look at glass, so can current pass through the glass? No. Because why? Because its resistivity is 10 power 10 to 10 power 14 ohm meter. So it's very heavy, very high, right? Similarly, rubber, ebonite, diamond, paper, right? So if you see, these are all having highest resistivity. For example, wood, right? So these materials are called insulators. Insulators means which will not allow the current to pass through that. So generally, the electric persons, right? The electricians, they usually wears shoes, and also they wears the gloves, rubber gloves. So why? Because those are the insulators. They can prevent them from the electric shock. Okay, so that is about Ohm's law and the resistance and resistivity. Now let's look at a couple of problems. Okay, let's look at this. The potential difference between the terminals of an electric heater is 60 volts. So an electric heater is there in a household, and the potential difference between their terminals is 60 volts. When it draws a current of 4 amps from the source, what current will the heater draw if the potential difference is increased to 120? Okay, let's say we have two values here. So let's say V1, that is the initial potential difference, that is 60 volts. That is across the electric heater. And then I have I, which is the electric current, that is 4 amps. Now, what current? Okay, so it's basically I1, I know in the initial condition. Then V2 is given, that is 120 volts. When the potential difference is increased to 120 volts to the electric heater, then what is I2? This is what the question is in short, right? V1, I1 is given, V2 and I2 we need to find. So what is happening here? For the electric heater, the potential difference is applied from 60 volts to 120 volts. It is increased by 60 volts. Now here, from Ohm's law, what is Ohm's law states? Ohm's law, V. So V by I equal to R, right? Now, for the electric heater, that's a consumption of, that's an appliance which consume the electricity. So that will also have an resistance. So first let's find what is the resistance of that electric heater. So R equal to, can I say V1 by I1, right? For the initial scenario, that is 60 by 4. That means R equal to 15 ohms. So this electric heater is having a resistance of 15 ohms. Okay, that will remain constant. Now, from here, I can say R equal to V2 by I2. I can write that, right? V by I is R. So then, what is I2? I2 is V2 by R. Then what is V2 here? 120 volts. It is increased from 60 to 120 by 15. So 3 5s, yeah, or 15 ones and 15 eights. So I2 is 8. What are the units? Amps. So when you increase the potential difference, the power supply to the electric heater from 60 volt to 120 volt, the amount flowing through the electric heater is increasing from 4 volts to 8 volts, because that's what the Ohm's observation is. V is proportional to I. More the potential difference you supplied, more current will flow in the circuit. That's evident, right? When 60 volts is supplied, 4 amps current was drawn in the electric heater. When 120 volts is supplied, it is drawing 8 volts, 8 amps. Okay. Yeah, these type of problems are important. Okay. All right. So let's see another one. So how to do this? A wire of given material having length L and area of cross section capital A has a resistance of 4 ohm. So a wire is given of some material whose length is L and the cross sectional area is capital A and has a resistance of 4 ohm. What would be the resistance of another wire? Okay, so let's say I have two wires here. Let's say AB is one wire and CD is another wire. Another wire means made of a different material. Okay, now for this, the resistance is 4 ohms. So R is 4 ohm for that, or I can say R1, right? Here R2, R2 I don't know. Okay, and what is the length of the wire is L and the cross-sectional area is capital A. Now, what would be the resistance of another wire of the same material? Oh, okay. Sorry, guys. So it is same material, but a different wire which has different length and cross-sectional area. Here, so L and A, right? Let's say, okay, let's do this. L1 is L and A1 is capital A. And here L2, it is the same material but different length. So same material having length L by 2. So half of the length. So only half of its length is there. And the cross-sectional area is double. That means this is bigger. Understood? The thickness is bigger. So A2 equal to 2A. Now we know what is R? R is proportional to L by A. Right? So from this, can I say R1 or R I can write as rho L by A, right? As it is same material, rho is constant. So if I say R1 by R2, can I write like rho L1 by A1 by rho L2 by A2? Why rho is constant here? Because it's the same material. Same material will have same resistivity. Then R1 I know, right? So or I can write this as R1 by R2 equal to L1 by A1 into A2 by L2. In other words, I can write R1 by R2 as L1 by L2 into inversely proportional, right, to the cross-sectional area. So A2 by A1. Or you can use this as formula for your future problems. So R1 by R2, R is proportional to L, so L1 by L2 into A. With area of cross-section, it is inversely proportional, so A2 by A1. Okay, that you can directly use that. So I just explained you how we got to this formula. Now just substitute the values. What is R1? R1 is 4 ohms by R2 I don't know, so I need to find. So let's keep as is. Now L1 is L and L2 is L by 2 into what is A2? A2 is 2A by A. So A gets cut, L gets cut. So 4 by R2 equal to 1 by 1 by 2 means it becomes 2. 2 into 2, that is 4. Then what is our R2? R2 becomes 4 by 4, that is 1 ohm. You understood? So what happens to the resistance of a wire if the length is reduced to half and the cross-sectional area is double? Here it is reduced from 4 ohms to 1 ohm. So a thicker wire will have lesser resistance and allow more current to flow through it. Understood? So that's how you can apply the principles that we have learned in this type of problems. Here the very simple principle is how resistance behaves with length of the wire and the cross-sectional area of the wire. So R is proportional to L by A, like that I got R1 by R2 equal to L1 by L2 into A2 by A1. If I substitute, I can find what is R2. Hope you guys understood, right? So in this session, what we covered, so we have covered what is Ohm's law. So Ohm's law states V or I is proportional to V or V is proportional to I. And that constant is resistance, that is V by I equal to R. And R is the resistance offered by that wire. And the units are ohm, right? And then how resistance behaves with the different factors, right? Length and the cross-sectional area. R is proportional to L and inversely proportional to the cross-sectional area. And that constant we got as resistivity, that is rho A by L, right? And resistivity of a particular material is a constant. And the unit of SI unit of resistivity is ohm meter. And then we looked at various materials and their resistivity values. And then we solved a couple of problems, right? So that's all for today's session. I hope you all understood the topic and I'll see you next time. If you have any queries on this, you can reach me on my Urban Pro profile. Thank you guys.